Hi, welcome back. Today we're going to take a look at a update to the MS-DOS C compiler setup we had before. That was running under QEMU and Microsoft C 4.0, I think, compiler, and it was working. The idea was to convert the Dungeon Raider code base to run on DOS, and that was a bit patchy. The support for Microsoft C 4 is a bit rubbish. Lots of stuff missing in the libraries. Anyway, so I've taken a different approach. I've published this information to a Git repo, and it's called DOSBOX Turbo C. So it's using Borland Turbo C 2.0, and it centers around a Python script and uses DOSBox for automation and handles the process of all the orchestration of the configuration both on your local machine and in the emulated DOS environment. It's relatively straightforward to set up. There's a few steps, and we'll go through that in a minute. But the actual result, I think, is pretty cool. So there's quite extensive documentation. I'll share this link on the post, which shows you how to use it. Let me give you a very quick demo of that. So here we're going to run this Python command. We're going to do a compile and run against this source directory, and there's a couple of files included in that Git repo just to make it easy so you can start work straight away. So if I run that, DOSBox loads, it compiles and runs the application. Very, very simple app. Doesn't do much, and you close that and the script ends. Very, very simple, easy to use. You'll notice here that the compiler result is sent back in here. So essentially it's running almost as a headless way. I could have hidden it even more, but hey, whatever. This is probably good enough. In order to get this to work, there's a few steps you've got to do. Back in the day when I was doing the work with QEMU, it centered around an image file. So there was a hard drive image, and that had MS-DOS 6.22, and that was all, what I thought was the right approach. It did work, but the way it interacted with files on the host machine was a bit rubbish, and DOSBox is actually so much simpler, much quicker. I managed to get it to work now properly and tamed it. So the script runs in various modes. You have compile only, so I can demonstrate that. So compile only, that will run, it will compile the file and then stop. Okay, so all it does is compiles, returns here, and there's the result. It doesn't try and run it. Compile run is what I showed you earlier. The other one is run only, which just runs DOSBox. But there's a reason for that. It's DOSBox in the mode that DOSBox has been configured to run with the emulator, which is a crucial thing. So by default in DOSBox, you've got Z drive, which is the boot drive. You have C drive, which has been conveniently labeled as the compiler drive. So there's only one directory now, it's TC, which is Turbo C. And then D is the data drive, which is, it's fortuitous naming. And these are all the files that we've got. So these files are the files on your local machine. So all you actually need is that file there, and that file there, and subdirectories where your source code is. Everything else is dynamically generated. So the way this works is the first thing you've got to do is you download a copy of this Python script from the Git repo. You then find a copy of this, which is the DOSBox config file. So if I go to my Windows machine and I say data, if I go to local and find DOSBox, then the config will be in there. So what you do for your machine and your version of DOSBox is you'll grab hold of a copy of that and dump it into this path here. And then what you'll do is open this up and go right to the bottom of the file where you see auto-exec. And at the moment, anyway, the best thing to do is just remove all the lines in there and replace it with this RG compiler commands token So you need hash rg-compiler-commands hash, and it replaces the stuff in there with what it's actually going to be like when it launches it. Every time you launch it, it creates a new custom config, and actually the config doesn't really change from run to run, but it's sensitive to the directory you're in and all that kind of stuff. So the result is actually this here. This is what it's actually running, DOSBox. So you see here it mounts the C drive, and I've put my DOS Turbo C in emulators / DOS-TC, and the development, the data path is dev DOSBox-Turbo C, which is this directory here. All it then does is set the path to include Turbo C, flip to the D drive or data drive, and run the compile.bat. Now compile.bat, you can't see that. You see that here as part of the repo because it's generated dynamically each time. So that's compile. So it's running in run DOSBox only mode. Okay. So if I click quit, it actually, unfortunately, it keeps the queue, but hey, it does actually quit. If I change that to compile and run, okay, then it changes to this. So it's compiling the file, it's running Turbo C with these files, it's piping it to the result, which is how it gets the data back, and then sends a signal back that I'm ready now, sends any standard errors out, and if it exists, and it clears the screen and runs it in this case. The compile only is the same, but just removes those two bits. So that's dynamically generated each time you run, which is quite cool. That means if you change stuff, it's easy. At the start of this file, you'll notice that there's a bunch of things that you have to install. There is actually a requirements text file, and all I've got as custom is keyboard and psutil for the keyboard interaction, but also psutil, which is part of the process management for when it's able to kill the DOSBox process. So you can run that, you can pip that in, that's easy enough. And then down here, you have to make sure that these are correct. So when you go to DOSBox and you open file location, and then in there, you will look at open file location for the shortcut, right? So this will be your path, right? So if we right click on there, look at that, then that plus that will be your complete path, okay? And that's what has to go into here. So that's the path to the DOSBox program itself. The DOS Turbo C path is this one, and I'll show you how to construct that in a minute. But the idea is that you only need one copy of that, and it's outside your source control. It just sits on your drive in your. I've got an emulators path and millions of emulators, but that is universal. So it sits there. There's no temporary files, none of that stuff. It just sits as part of DOS. The one above it, the data path, uses this function to get the path to where you currently are, and then it stitches together your new config. All right, so that's how that works. So how would you get a copy of Turbo C? Well, I'm not going to tell you that. I'm not going to include it. You'll have to go and search for it. And typically it will come down as a bunch of image files. So floppy drive images, typically. I've found them in various formats, 360K or 1.2 meg, whatever. Turbo C version 2 is not that big. Essentially, you end up with a directory of setup directory. Now that setup directory can in here, if we look at this path, so we'll go to the emulator. This is the result here. So this is Turbo C on my local machine. Obviously, you can't run these because they won't run on a modern OS. These are 16-bit applications. What I actually did was have a TC setup file in there, TC setup folder, I should say. And then from DOS, you do the run only command. It will then launch the installer. You specify the source of that C drive in this case, and the directory setup TC, and then you'd specify the target, which is just TC, and it'll go through the process of installing it. The installation is really straightforward. So let me show you how you do that. like I say, I'm gonna skip the bits. Let me show you how. So let me show you how I do that. I'm going to skip some of the bits, downloading all that kind of stuff, because it's not relevant, and you know, that's up to you guys. So TC setup. So I've got 3 image files here. They're floppy drive images. These are actually 720K. They're 3.5-inch images. I'm going to extract it to here. And I'm going to do the same for these. Extract here. Okay, so we've now got a bunch of installer stuff. Okay, I'm going to delete this. I'm also going to go back here, and we're going to find the run only. Okay, so if we now look in here, we've got the TC setup. So if I go to TC setup, there is a install program. Install. Okay, great, fantastic. So I'm going to use C drive, which is really cool because it means it doesn't have to be looking for floppy images, which is brilliant. So I'm going to install that to TC. Yep. Brilliant. Start installation. So now it's going to go through the unpack process. Now it does tell you need files equals 20 in your config, which is already set actually in DOSBox, and then you add this path thing here. So this is what we saw earlier. If I then go to here, oops, go to the root, I've now got TC there ready to rock. Okay, so if I go back to my DOS machine, my Windows machine, I can then delete that. So now I've just got TC. Okay, so let's see whether I've blown it up. So I'm going to do compile run. Works perfectly. Fantastic. Now this has been a labour of love in some ways. The original process used lots of batch files on the host, batch files on the guest machine. Bloody nightmare. Using Python to automate it. I was starting to use PowerShell, and that would have been okay, fine. But Python seems a bit better. I think I'm hopefully, I haven't tested it on Linux yet, but in theory, most of it should run straight away on Linux and on Mac OS. So that would be cool. I've been careful to make sure the pathing is agnostic to Windows or Linux. But that's untested. So that'll be a next step really to see whether that can be done. It's been great fun. So let me just show you quickly before I stop this. Breaking things. Breaking things shows you stuff. So if we go in here and I break that file, okay. Notice that what I've done is this is not just a simple. Well, it is a very simple set of tests, but it's not simple structure in some ways because it's not just one C file. A lot of examples have one C file, but this is test.c, and then there's an include test.h there, which includes this stuff, some externals, and there's a load file thingy method. It also has examples of the sort of comments that Turbo C likes. So the inline dash doesn't like that. So you've got to be a bit careful. These old legacy compilers are slightly less flexible than modern ones. But as long as you know that, and this is an example of this C program including its own definition file, a bunch of libraries, but its own definition file, also a utilities file. So in utilities, it will define itself, right, this is utility header and there's a test function. All it does is print a message. It's very, very simple. But you see here it's including its own libraries and including the utils header. So when you're actually compiling this, and now it'll break because I've removed that bracket, it's doing multiple things. In the compile step, it's actually got test and utils.c. Now you could, in theory, change this with anything you like. So when you're looking at this stuff gets transposed to here. So you could do all sorts of things, include assembler files, whatever you like. A future modification will be using the make file, and I haven't automated that yet, but I intend to. right now I'm having too much fun with just messing about with this, and the focus for this is to see if I compile the Dungeon Raider program. So this test thing does a few things over and above what you think would be a normal test. So it does load a file, so there's disk handling. It prints stuff to the screen, obviously. It puts characters in a certain place. It grabs characters from a certain place on the screen, and it plays a noise and does some basic keyboard input. So it's not particularly complex, but it does test a few of the things that I need in order for Dungeon Raider to work at all on a target system. In this case, MS-DOS. Right, enough of that. So let me save that out. We're going to do compile and run, but it won't run because it will fail. All right. So now it's gonna wait there because it's waiting for me to either close this or press Q there, and it's telling me there's errors. So what's really cool, if I did that again, but compile only, then it will do that, compile it, and then that'll disappear, which I think is really cool. So it's just waiting. So essentially you're doing it, if you imagine that window wasn't even there, then you're compiling 16-bit stuff purely in this terminal here. That's all you've got to do. There's a foible with the way DOSBox works, which I may address, which is when you load it, actually it hides a window below it. There's two windows that open. There's the actual DOSBox, and then there's a child window that opens. And I can only hide the primary window, not the child window. But that's for the future. But you can see here it's moaning that there's stuff broken. So it obviously couldn't run the thing because it's broke. And it's up to you to figure that out. But we know that actually it's just that there. So we can we fixed that one. What I'm going to do now is maybe break something else. Bob he won't know about that. So let's try that one. Okay, so undefined symbol, Bob. Doesn't know what that is. Brilliant. It's really, really easy. So I think that's actually a very nice, easy to use, very lightweight way of compiling 16-bit stuff on your Windows machine in personally my editor of choice, which is Visual Studio Code. But it could be anything. It doesn't matter what it is. It will run on just about anything that can support DOSBox. In fact, I can't think of anything that it wouldn't run on. As long as it supports DOSBox, it should run fine. I really, really love the way DOSBox handles the drive mounting. The idea of being able to mount multiple volumes so easily and for them to run so smoothly. With the QEMU, I was trying to raise compiler results and it was working, but it was very twitchy and really quite slow. It wasn't always obvious that things were being shared. So when the compiler finishes it doing its work, it sends stuff to this ready.inf, and all that is a done. That's all it is. But what's great is that the program is able to monitor that. If we have a look at that, so it's monitoring the trigger file. And as soon as that's then visible, it will grab the results of the compilation, which is really quite cool. It makes it quite seamless. Anyway, so this is the first, well, it's probably about the 16th version of this, but this is the first released version of it. And let me know what you think. It's been fun making it, really has, and I'm hoping that I'm going to have some success with Dungeon Raider and a few other things as well. If you've got any ideas, let me know, and yeah, I'll see you next time. Cheers.